Now let's look at how we can calculate the Gibbs free energy for a particular process. So remember, the Gibbs free energy is equal to delta H minus T delta S for the system. And if we know the enthalpy and the entropy changes and the temperature for the process, we can calculate delta G. But we can also use the fact that, say, for reaction, we can define delta G formation, similar to what we did with delta H formation, and we can use delta G formation of the products minus delta G formation of all the reactants. And therefore, we can use the delta G formations to find delta G reactions. So let's do an example. Say we have our methane combustion reaction. And we want to know delta G for this particular reaction. It's just going to be the Gibbs free energy of formation of carbon dioxide times 1 mole plus 2 moles times the Gibbs free energy of formation of water in the liquid phase minus delta G formation of the reactants, methane, and we have 1 mole of methane, and then minus 2 moles of oxygen, so delta G formation of oxygen gas. Now, these delta G formations are a relative scale, and we define the 0 point as the elements in their standard state and most stable form. So oxygen, O2, is an element that's in its most stable form, O2, in its standard state, meaning 1 atmosphere pressure. We define delta G as being 0 for the formation of an element in its most stable form at standard state, 1 atmosphere. And so the delta G formation of oxygen would be 0. So remember, delta G, delta H formations are relative scales, so of elements, and their most stable form is 0. But entropy is an absolute scale, and so the entropy of an element is not 0, except at absolute 0, which we can't obtain. Okay, so we go to a table and we look up the enthalpies of formation of each of these species. It's negative 394 kilojoules per mole, and we have 1 mole of carbon dioxide. And then the other product, 2 moles of water in the liquid phase, that's negative 237 kilojoules per mole. And then we subtract the reactants. So we have 1 mole of methane, negative 51 kilojoules per mole. And subtract 2 moles of water, 2 moles of oxygen, but that's an element in its most stable form, and at 1 atmosphere pressure, that's 0. So this gives me a delta G of reaction of negative 817 kilojoules. So we see that the Gibbs free energy of this reaction is negative, which means it is spontaneous. So delta G negative means it's a spontaneous process, and we already know that the combustion of natural gas is spontaneous. Once we get it going, ignite it, it occurs spontaneously. And so even though the reaction delta S is negative, the heat dumped by the combustion reaction into the surroundings more than makes up for that. And so the entropy change for the universe is positive, so delta G is negative or spontaneous for the process. So remember, delta G negative, spontaneous. Delta G positive, not spontaneous. Delta S of the universe, positive, is spontaneous.